So first, I'll just walk you through some of the healthcare models and types, and I'll show you the models hub. And after that, we'll dive what are the different types of LLMs, SLMs, what where to use which model. LLMs are good for a lot of things, but they're not good for everything. So there are some other models for other use cases, for example, medical coding, etc. So we'll look at those, where to use which type of model. Why do we have specific models for different applications? For example, we have tune models for RAG, LLM tune models for RAG, and different models for summarization, Q&A, and NER. Why do we do that? What's the point of that? We'll look at that. And yeah, I'll show you LLM loader. We'll then dive up, not too deep, but a bit deep into the coding session, where I'll show you some real examples. We'll play around with the models, run them on some example text, some data, look at the results and understand what's going on. Yeah, that would be for summarization, Q&A, and then NER, and then I'll just discuss over RAG models. Then we'll have a break, and then we'll look at LLM Studio and a new solution, real-time voice assistant app. This is, yeah, I'll show you a video of it. How does that work? What's going on in this? And then yeah, we'll hand over to Mohammed. Okay, so I think by now you would already know that Spark NLP and Spark NLP for Healthcare are different products of Johnson Labs. We have other products as well, but like medical chatbot, Gen AI, etc. But these are the ones where we actually have to do some coding and understand what's going on, because even in, let's say, Gen AI, if you click on a pre-annotate button, it's these pipelines that get executed underneath. In the case of medical chatbot as well, it's powered by LLMs and RAG, right? So again, we need to understand what's going on with the models in the first place. So what are the different possibilities and use cases and features of our library? While LLM is something that is a very broad statement, we have to define or look at the tasks that we can perform with or without LLMs or with bespoke models. So for example, we have named entity recognition capabilities, entity linking. So let me show you. So what is named entity recognition? So if I go here, I'll just go here, clinical NLP. Let's look at any use case. So this is what named entity recognition is. You have text available and you extract entities or pieces of text, chunks, as named entities like this. And then you stitch together and then come up with your use case, fulfill your use case. But this is what, in simple words, a named entity recognition model is. You get named entities chunks from the text. And because it's a DL model, you don't need to, it's not keyword based. That's the whole point. Okay. Then we have entity linking. This uses named entity recognition as the core building block and then assigns these chunks to codes. Let me show you what I mean. So yeah, entity strict terminologies. Let's just look at a easy one. Okay, so you see non-productive cough, and then it's a problem. That's a named entity. Named entity ends here. And then you have the clinical entity linking model, or what we call resolver models. Those actually take those named entities, these chunks, and then resolve them to code. So this is a layer on top of the named entity recognition models. So another layer on top of that is assertion, where you check how severe a thing is, or if it's related to something in the past or future or hypothetical, like these are just some guidelines, etc. Let me show you. So this is another layer. And all of these layers are used for different things. For example, this coding layer um, translates to codes, which is useful for billing purposes, right? But assertion layer, let me just show you what does that mean. Um, so assertion layer would be used to filter those named entities. You would only want to look at things that are in the present, or you would want to look at historical things for that matter. Then you just filter out those things. So it looks at the context around, and it looks at the chunk, and then we get the assign the tag to it, and then we can just filter the chunk based on that tag. Okay, so that's assertion. Again, for both of them, the baseline is the named entity recognition model, and then we have relation extraction. Um, let me show you what that is. Okay, so relation extraction looks something like this. You have different things in different, like you are extracting named entities, but then you want to link them. For example, something happened in the past at a specific date, then you want to link date to that so that you can process it later or just store it in your records. Or if a drug caused a problem, then you would know, okay, this caused that problem, or um, two problems are related to each other, or a body part is related to each other, to a parent problem, or let's say pain in neck, then you would tag neck and assign it to pain, right? Or you can have stage in oncology. You could have the primary histology type, and then you could have stage and grade and topography, and then you can link all of these things to the primary histology. That's the power of relation extraction. But then again, all of this is built on those core named entity recognitions, those chunks that come from these models. Then you have de-identification and then Q&A. So then you have de-identification. De-identification is also based on named entity recognition model, because we just extract chunks and then we de-identify them. There's a full session on this, so I won't go into much detail on this. And then, those are all the things that are core named entity recognition based. Then you have question and answering, summarization, data enrichment, etc. Those are not necessarily NER based. Those are very predominantly LLM tasks. So we use LLMs or SLMs over here. Now here's the thing. What I just said, the whole point of explaining all of this was just to communicate that while you can just ask ChatGPT or any LLM that, okay, give me the primary condition in this node, and it would give you an answer. There are existing models that give you more control, and you can use those ones as well. Just to give you an idea of what the core logic looks like. So all of these tasks can be performed using LLMs, by the way. Yeah, like I said, in entity recognition, you could just ask an LLM and it would give you that. As a matter of fact, some of the tasks are better served by LLMs, or I wouldn't say necessarily named entity recognition is one of them. I would call it a toss between the bespoke models that we have as well, and LLM. And the reason for that is LLMs can hallucinate in the sense that they might not necessarily pick from the text. They try to reason. So that gives you some false positives. In the case of named entity recognition model, there is literally, the possibility of a false positive is quite low. And if you have a very specific kind of use case for which the LLM is not picking up anything, for example, you have your own ontology defined, or you're extracting some genes, some very specific genes from something that the LLM has never seen, then you can just use these models or train one with relative ease. Entity linking, I'll come to that later because this is a unique one. Assertion status, I would say LLMs are better at this. Relation extraction, LLMs are better than this. I'll show both of them later. De-identification, I would still say that bespoke models are better because of more control. But yeah, Q&A, summarization, data enrichment are all tasks that are where LLMs supersede everything. Now, Entity linking, where we actually have to link concepts to codes, is one of those areas where you would not want to use it. And the reason for that is it's not designed for this specific kind of task. What do I mean? For example, we look here. I want to assign ICD-10 code to this condition. Let's just say there are, I don't know, 50,000, or let's just say 20,000 ICD-10 active ICD-10 codes. And if you ask an LLM to first find this and then assign a code to them, that is not the right thing. First of all, the LLM might be trained with older data. So it might give, and it will, I can even show you that example. It will give you outdated code. For example, I just asked ChatGPT here that, okay, ICD code for pulmonary edema, it said J10, JD1.0, that is fine. But what's the HCC code? This is not the correct one. This is for, I don't know, cardiology related thing. ICD code for J81 is something totally different. And it changes every year. That's the main point, is that it changes even biannually for that matter. So you cannot keep updating your LLMs in that case. So what you do in this case is even if you want to use an LLM, you use it to basically perform named entity recognition and then you link, or you use a RAG-based solution underneath to actually link them to codes, or a simple k nearest neighbor with embeddings, etc. But you should not, and you do not ask an LLM to give you codes when the possibilities are, I don't know, 10,000 different codes, right? So it's not entirely the job of this. Okay, so these are just some of the broader concepts, because the reason why I'm trying to explain all of this is because although we have models for LLM models for NERs and assertion and relation, we do not have an LLM model for entity recognition because of the thing that I just shared, because of the reason. And then we have the models for every other thing that's listed here. Okay, so let's go over some models. I'm just gonna go to Models Up and show you how you can search different models. So now that you understand what so if you have a use case, first you need to understand what do you want to look at, or what do you want to search in the first place. Like I said, if you're just looking for mapping to ontologies, then you can just go to Models Hub, and then over here you can just say ICD-10 for that matter, and you would get pipelines of models for that map to ICD-10. If you want to do summarization, then you can just type in summarization over here, and no, Spark NLP for healthcare. Okay, so it's the model, it's our Models Hub, and you can just search online Spark NLP Models Hub, and it should direct you over here. And over here we have tons and tons of models that you can use. For example, this one that I'm just going to show you how to use, but you see we have LLM loader, and then we just define the name of the model dot pre-train, just like Hugging Face, and then you get a prompt. We give a prompt, and then you get the response. It is very simple. Now, all you have to do is just install the library, and then just use the LLM loader import and just run it. Now, there are a couple of things here. The benefit of this is that so for these larger models, by the way, one thing, you do need to have a GPU running. That's I think a given. That's natural, or that's understood, or that's implicit, because you cannot just simply run these larger models on CPU. I mean, you can, by the way, if you just do this, start your session without GPU is equal to true flag, then you will run it on CPU. It won't stop you, but the speed would not be as good. So you need to run it on GPU, and then for that you just need to have a flag in your Spark session. When you create your Spark session, here I can just either use this, or when I do it like this, Spark is equals to Spark NLP underscore JSL.start. While I specify my license and other things over here, I just need to have a flag over here that says GPU equals to true. So this would run it on GPU. Now, in order to run that, of course, you need to have your libraries and other dependencies in order, but that's it. And then you can just run an LLM and use it accordingly. Now, coming to LLMs, what are the different types and where do we use them? Okay, so before jumping directly into LLMs, I would just go over SLMs. Those are small language models, and we only have them for a few different tasks like summarization, etc. And those are very performant on CPU as well, and you can even deploy them in Spark, and you can process millions of records with them. That's the main point. I'm just going to show you. Yeah, for example, this. If you have radiology reports that you just want to summarize, then just go over here. It's a pipeline, and you just input your node, and you'll get an output. And you can run this one on CPU. It would run just fine because this is not a large model. It's kind of like a small language model, less than 1 billion parameter. Yeah. Okay. Now it's time to go over this thing. So yeah, different types of LLMs and SLMs we have. So first thing is SLMs, as I just explained, that is less than 1 billion. You can run them on CPU. We have a limited limited models in that category, and the reason for that is simply because of the size, right? You cannot do too complex things with a smaller model. So for SLMs, if you just want to run on CPU, you can just do some basic summarization, some basic Q&A. I wouldn't push too much on the Q&A, by the way, but still. Okay, and Q&A also has two types. I'll go over open book versus closed book later on, but yeah. And then we have LLMs, which start at about 1 billion plus parameters, at least for now. For that, we have Med-S, that's 3 billion, Med-M, that's 7, 8, 10 billion, even till 11 billion. And then we have large, 40 billion, 70 billion, etc. So these are general purpose NER medical LLMs that we have. Then we have medical RAG. That's a smaller one, and the reason for that is it's just is tuned on RAG datasets to give you better performance while if you want to put an LLM if you want to pair it with a RAG architecture, like you're getting chunks from a vector DB and you want to discard chunks or summarize chunks or just give you the answer to the question when you need a lookup. So there's a specific model for it. And then we have a very specific model that's MED-NER. And that gives you, I'll show you, and you should like it because that's a very cool model. So why do we have these distinctions? Is because these are designed for different use cases. For example, Med-S, Med-M, Med-L, these are general purpose NER models. Oh no, general purpose LLM, sorry. These are general purpose LLMs. They can do everything you ask them to. You can ask them to summarize, they will do it. You ask them to, you can ask Q&A, contextual Q&A. That's fine. It's just like a chat GPT, very simple, but healthcare specific. So, but when we say healthcare specific, it means that they should have more knowledge about medical jargons. They should not hallucinate, etc. Like I said, RAG is something that you use with RAG, and NER is something very specific. It incorporates NER plus RE into one, and it gives you a JSON output that you can directly use for API calling. Because the other models, although you can ask them to give you a structured output, you can do that, but the NER model is designed to do that. So, and it's very small, by the way, and you can even run it on CPU. I mean, it would be a bit of a stretch, I would say. I would still not recommend, but if you just start testing and just want to see the performance, then you can do that. Ideally, you should run it on GPU. Yep. Okay, now I'm just going to go over these models one by one. So Q&A. So we have two concepts over here in Q&A. One is closed book, one is open book. Closed book is very simple. You have we're talking about some older models here. Like if you just ask ChatGPT, what are the symptoms of, let's say, asthma? That's a closed book kind of thing because it just gives you answers from its database, right? What it has learned, not its database, but what it has learned, the distribution of data it has seen. So that's a closed book kind of thing. You don't necessarily want that generally. because it, like I said, the factual correctness could be lower because concepts get updated every now and then, and once a model is trained, it does not get updated very frequently. So uh, closed book Q&A is kind of like I wouldn't. I see less of a use case. That's my main point over here. Main thing is open book Q&A, like here. So you have a text and you have questions that you want to extract useful information from that piece of text, and you can just do that over here. Let me show you some live demo. So we have a document that's a, what's the document? So we have a note. Patient has this, some hyperlipidemia, some DB, and yeah. And we just want to extract historic conditions. So we just say, ask the model, okay, list of past medical history. You would see that it would just exclude other things like infarct, myocardial infarct, etc. Um, but it would just only list out things that are historical. So this is a very general LLM. And again, like I showed, how do you use it? You just start your Spark session and just LLM loader.load, and that's it, nothing more. And then you just dot LLM loader, so you load model name. You can define by default, so you need to define EN, that's the language if we have multiple language support, and then it is models, and yeah, so that's it. Okay, so yeah, and then how do you infer? You just put in your prompt. I've created a wrapper to make it clean, but by now you would already know that we have document assembler, and then that document assembler feeds into this LLM. So it's an additional stage at the very start. That's it. In general, um, yeah. In general, you don't need to do that. Just providing your document and a prompt, so you can create your own prompt as well. By the way, this is what these models were trained with. Like you have a placeholder and you have document and then you have your own question. This using this structure would give you a bit better output, I would say. Set and predict. So this is just one hyperparameter. Try to keep it clean. It's just maximum tokens. Like if I just do 20 or something, yeah, it's just the number of output tokens. Okay, and then we just do dot generate. So two functions that you really need to worry about, like set and predict, and then dot generate your prompt, and it would give you the answer. That's pretty much it. Like I said, you can ask literally anything. You can say, okay, I want to extract different sections from a very large node, and you can just simply say in 5 sections, summarize the document. History, assessment, examination, management, and you would run it and it would just give you like this. So it's very easy to use. There's no, yeah, nothing fancy going on over here. So this is very simple Q&A. Similar to this is the summarization model. It's literally the same thing. We have LLM loader, and you just use your med-s. Okay, so let me explain a few things over here. Different types of you can find all the all the resources over here. So you go to Spark NLP workshop. Well, let me just show you Spark NLP workshop. You type it in Google, go here, GitHub repo. In here, go to healthcare NLP, and over here, all notebooks are present. Everything that I'm covering are here. So for example, LLM loader. You would see loading medical and open source LLMs. And whatever I'm trying to explain over here is already here. So you can literally run it on Colab without just with the trial license. And okay, so I didn't explain. Let me explain a few things over here. What are the naming conventions? You would see med-s is the 3 bill, as I just said. Med-m is 10 billion, and yeah, and med-s because as I told you that med-s NER model is based on med-s, so it's med-s NER. And that's it. Naming convention is also pretty simple. Okay, one thing is that for the most part, if you're running it on a beefy GPU and you're not thinking about productionizing it, then I would say just use the Q16. So what are these Qs, by the way? So these are different quantizations. Different quantization. So these affect the speed of the model, and this also affects the performance of the model, the qualitative performance. So best one would be Q16. It would give you the best output, but it would take more GPU memory or CPU memory, and it would be slightly slower as well because it has to compute full 16. So it's Q8 is the next one. That's 8-bit, and then you have 4-bit. So in general, for experimentation, I would say just use Q16. For productionizing, you can then, if when you're done with everything, you can use Q8. Yes. The difference in performance, the difference in memory consumption is simply divided by 2, roughly divided by 2. But the difference in performance is not that big. This is what we've seen and what the literature also says. It's not just us. There's a full research on this. So yeah, Q8 could also work if you don't see any major performance degradation. Q4 is something where I would just suggest to use when you are running it on an edge device, or you're running it on you're running it only on CPU and you're just doing some basic experimentation. Q4 is for that. Or your task is not that complex to begin with. Let's just say you just want to extract 1 or 2 things from your node. You're not generating long sequences. Here's the main point. If you're generating longer sequences, the more it takes for LLM to be correct. In the case of Q4, just make sure that you have long input sequence and long output sequence. Then it would work just fine. Otherwise, it will hallucinate because this is very heavily quantized. So yeah, well, I'm just trying to explain when should you use which type of quantization. But yeah, in general, just use Q16. Yeah, it's the same thing. I'm just giving you a live demo over here. So right now I'm using the Q16, like I said, because I'm running it on GPU, by the way. So yeah, I can use the full power of the model. So yeah, so this is summarization and this is Q&A. It's very dependent on your input prompt. We've kept it open. Our older models did not have this, but now you can literally define your own prompt. Now, summarization. There are a couple of things over here. Let me go over here. Healthcare NLP. I have a question. What if you want to summarize an entire dictionary, or you have a very long piece of text that is beyond the contextual limit of the LLM model? Because one thing that I did not explain to you is context limits. So the M models are 8K, S models are 1 to 8K, but I would not go above, I would say 4K for these ones. You can, it will never give you any error apart from any memory outflow overflow, but the performance would start to degrade, to be honest. After you hit 10K or something, the performance of the smaller models would start to degrade. Very simple. I'll explain that later why that happens, because there are certain phenomena that are running underneath, and those are called loss in the middle, etc. I'll just explain these things later. But in general, the more context an LLM or a model has to deal with, the more it tries to look at only the start and end, the left and the rightmost ends of the context, and it pays less attention to what's in between them. That's just some general behavior of the attention mechanism. So, which is why you would start to miss artifacts that are present somewhere in between as your context length increases. Now, that's the reason for S, don't go beyond this. For large one, yeah, of course, it's 128K. you can go till, I don't know, even 50K context, whatever. But then it's a larger model. You need much more CPU power over here. Sorry, GPU power over here. These would not even run on CPU. And if your use case is just to summarize, then we have some better alternatives, by the way. I'll just touch up on that. So in the case of summarization, this, we have two concepts, abstractive and extractive. Abstractive and, yeah, these are the two concepts. This is what LLM does. So what this does is it looks at the context, it looks at the entire input, and then generates a summary at the end, right? This is what LLMs do. They look at everything and then generate new text. This is called abstractive. Extractive is when you pick concepts and then summarize, and then let's say put them in and then generate output. So these are two separate processes over here. First, in the case of extractive, is you try to find areas of your input string of your document that have useful information available. So you extract. Then you have two options. Either you can just jumble them up and generate a summary at the end, or you can then pass all of that information to an LLM to write it for you nicely. This is something that can be done. But the main point is that you're using another model or another approach to extract useful concepts, and you can limit. This is the main point over here. You can limit your, you can limit your size of output at this stage. The more things you extract at the extractive stage, the lengthier your output would be. So you can just limit things over here. How do we do that? Here. So we have an extractive approach. And so we use sentence embeddings, and then those sentence embeddings are used to calculate the cosine-similarity, etc., between sentences and concepts. And then we just discard things that are we can even do some PCA over here, principal component analysis, and then just discard things that are not giving us any variation or that are of no use, etc. And then we can just have a extractive summarization wrapper on top. If you look here, you see summary size. So how do we use it? Pipeline is very simple. You have document assembler and the sentence detector and embeddings, and then extractive summarization, and then your summary size. This is the number of sentences that you want your summary to be of. You can have literally one sentence summary of a 10-page document. You can have 100, but that's the main point. You don't need to worry about feeding that entire document in a single LLM. Let me explain. If you want to, you have a document 50 pages, then in the case of abstractive summarization, what you will do is you will split, then you would summarize, or use RAG, or you would summarize, and then you would generate the output, right? In the case, still it would be very limited. In the case of extractive, that's not the point. You can feed your entire 50-page document, and it would calculate embeddings. That's perhaps only the most heaviest part. Once it has done that, then it's very simple. It would just look at things, find out useful things, and then just jumble up. There are some pros and cons of both of them. The pros of extractive approach is that, like I said, you can handle larger documents. The con is that, yeah, you can. Biggest drawback is the output might not look very clean. It would look a bit put up, like it's just slapped on. That's just I mean, you would not find flow between the sentences because it has literally just picked up sentences and jumbled them together. So that's probably the biggest drawback. The other one could be maybe it could leave out some useful things that the LLM might not, but then again, you can control that using thresholds, and you can control that using your length hyperparameter. So that's the pros and cons. For abstractive, it's the other way around. You would get a much coherent output, but you cannot first of all, the computation the complexity is much high. Second of all, yeah, you need to build a full infrastructure to summarize larger documents. So yeah, okay. So that's extractive versus abstractive summarization. Yeah, and the notebook for both of them are available, but in general, this is essentially it when it comes to LLMs. We just have some general purpose ones, and we you just load it using a single line. We can take a break here, and then I will start. On um, NER LLM, LLM Studio, and Voice Assistant, and I'll just go over there. Okay, so we can resume. There are a couple of things that I should explain a bit more in detail. So um, the reason why I explained NERs in the first place is because there are different ways, and we have, I don't know, more than 200 different types of NERs. Some could extract biomarkers, some could extract genes, some could extract oncology-related entities, some for internal medicine, some for radiology, etc. So the basic point is that these can be paired with LLMs in various ways. For example, we talked about summarization, right? So you can, instead of even using the summarization pipeline, the pipeline that I showed you, which relies on some naive embeddings, which might not be as enriched, you can even use those basic NER models to first run. So what you can do is run NER models on your text, extract areas of your document which contain entities, and then pass them on to the LLM to then summarize or write a nice output or whatever. You can even link them with assertion and then ontologies, the resolver models, let's say ICD, CBD, whatever. And then you can have an LLM write a nice output for you. So that is something that can be done. And that the benefit of that is you don't need to run um, multiple runs. You don't need to have multiple runs through the LLM because that is slow. So you just use these lightweight models, extract useful things, and then just give them to the LLM at the final layer. So LLM could only be the final layer, kind of like RAG over here. It's just that instead of matching it using using embeddings or keyword, you're actually picking up activations or picking up portions of document using NERs. This is something that we've done as well, and this works really fairly well. This even works with RAG. Okay, and I can explain that as well. So even in the case of RAG, there are multiple chunking mechanisms. You can have naive chunking, let's say based on based on length, based on overlaps, etc. But in the case, or you can augment that chunking with something like this, where you just quickly run your documents through different models, and then you just pick up information, and you just discard every other chunk, discard chunks that don't contain any useful information, and only keep the ones that have information. For example, I was looking at a really large document for an internal patient. We were working with a client, and out of that 4,600 pages, maximum the most of the pages were flow sheets. If you don't need flow sheets in your analysis or what you want to do, then why do you want to process 4,000 different pages? You don't need to, right? So in that case as well, we used the named entity recognition model to extract headers and sections within the full document, 4,600 pages. It took a couple seconds to do that, and then we discarded sections that were not required, only keep the ones that were required, and then we pass them on to the medical LLM that eventually essentially we wanted to link eight different HCC conditions with their severity, etc. And then we were able to link using LLM and give a nice output. We could have used relation extraction as well, but as I explained earlier, LLMs are better in that regard. So we just use LLM as the last layer. This is what can be done with the power of using these lighter models, and this speeds up your or makes your pipeline much more scalable. Uh, and this could apply in batch as well. So if you want to process 10,000 documents, rather than just naively running them through LLMs, first do a pre-process, just trim those documents down, and then run them through LLM. That would be a bit better and faster. So yeah, that's another thing. And not only that, you can even augment your input to LLM based on all of these goodies that you see over here. You can in your input to LLM, you can just simply say, okay, here are 10 different conditions that are found. Here are 10 different drugs that were found, and here are some of the codes that are linked. Here are the codes for the drugs. Here are the codes for the conditions. And now all you have to do is just link drugs with conditions and give a nice output along with their codes in a nice format. Fairly possible. You just use the medical M, the larger one, LLM, and it would do it for you. But all the pre-processing is being done by the lighter models, and that's the main point. Another thing. So one really big limitation here, which is why I said that entity recognition is one of those areas where you have to be a bit more careful which model to pick, because we've seen that. So on another customer project, we wanted to extract 100 different types of entities. Now, let me show you a model that does that. So very simple. This model extracts so many different types of entities with fairly good confidence scores and very good, precision recall, etc. Overall, is pretty good. And yeah, so 80 different or 100 different types of entities. Now, if you just pass a big chunk of node and ask an LLM and create a prompt like, okay, extract this condition, or say yes or no for certain conditions, because how do you actually do some prompt engineering is also, let me show you. Instead of, here's another thing. Instead of just simply saying to list, you can do a negation input, a negation prompt where you say either negate it or verify the output. That's a slightly easier task for the LLM to execute, and that way you would get even lesser hallucination or wrong output. That would be more factually correct, by the way. So in this case, I could not just simply say that here's a big chunk of node and then extract 100 different entities. That would just boggle. The LLM would not be able to extract everything out of this. That is where you have multiple options at that time. Either you can have multiple runs, you bucket those entities into different categories. For example, let's look at this one. So I could just simply do one run and say, okay, extract all of these things for me. And then I could say, okay, now extract vitals. And here are some of the vitals that I'm looking for: EKG, LDL, BP, etc. And then I could have another one where I could say, okay, now extract all the drugs, would give me more granular information: drug ingredient, dosage, form, etc. This is one option where I split one single run into 3 or 4 different runs. But then again, that's a huge, I mean, that's a lot of processing, right? If even a single document is taking a few seconds, then you've just quadrupled your runtime. Not ideal. So this is one of those cases where you would be better off using or starting with an NER model and then just using LLM as the last layer, because these models don't have any issue scaling up to even 400 different types of entities. They could do that because they're trained that way. Their output structure is totally different. Their output layer is totally different, like their token classifications. These are not Gen AI models, right? They just have to pick information from the text. So that's another use case where um, you necessarily you would use LLM in a slightly different way. This is what I'm trying to say. Either you don't use it or augment it using with a slightly basic model. Okay. So now we can come to NER model. So this is the one that I was talking to you about. So you would see that this is JSL man NERS. It says NER in the name. Oh, it's already loaded. Okay. Now, if you look here, what is the input and output? So it has a very fixed prompt structure. That's in our notebooks as well, but you have to just define a template and a text. Text is your document. What is template? Template is essentially a JSON. And inside JSON, it could be everything. So this model is a combination of NER, entity recognition, plus relation extraction in one go. This is the true power of this. You could say, for example, here, I'm defining drugs. If I just need the name, let's do it over here. If I just need the names of the drugs, nothing else, I could even do something like this, right? But because I need the name as well as reactions or dosage, etc., in that case, you see, so this allows you to have n number of concepts that you can link, extract, and link with each other. Well, I shouldn't necessarily call it n because there's obviously an upper limit. You cannot just simply have 10 different nested lists. That would confuse the model, of course. But at a basic level, you can extract and link. And you can have the output according to your liking as well. That's the whole point of it. The output you're getting is a JSON. It is. I could literally use this. For example, right now I think it's a string, right? I could literally do JSON.load this. No, import JSON. You see, it's a valid JSON. So you can literally use this for function calling, for APIs, etc. Whatever you define, your input, your template, you would get the same output only with filled in entities. So essentially in our input JSON, we're defining a structure as well as placeholders. Name, I'm telling it name is a string. It's a single string. It's not a list. It's a single string, so it knows. But reactions is a list. So I'm defining it as a list over here. And you see, let's look at another example. Or I could, let's just say I could take the same one, just delete it. I showed you I could just have it this way, but you could even have it this way. You see, it just popped, like it just did. Instead of a list, it respected whatever your schema is. Okay, let's look at another example. It's slightly more complex. So you have name, date, and that side effect on that date and the date of the side effect as well. So for example, and you have multiple, multiple drugs as well. So you have, so what we're looking at is the input is more along the lines of, okay, there was some adverse reaction to a drug, right? So Libner was taken in May, and then the reaction started to appear a few months later. So you see, that's the power of reasoning over here and understanding the context. May, it knows that it's related to the drug, but August is related to, not the drug, but the reactions. So you get the output like this. And again, you can use it in different scenarios. So I could just simply, I think, this, and it should only give me the name. You see, without any date. I can augment it, do whatever. But yeah, once you define a schema, then all you have to do is just adhere to it, and you would get the same output. Now, so this model is trained on uh, a blend of different NER datasets that we already had. So we in JSL, or we have datasets, very bespoke datasets for radiology. We have onco, we have for drugs, or drugs, and then we have internal medicine, and then genes, and etc. So this one is trained on all of them combined. So you don't need to necessarily find the one that is applicable for your input type. It would work with radiology documents or any other type. The same cannot be said about these NER models. I think I showed you earlier. These are very bespoke. Everyone is trained to do a specific task. So yeah, when you're using these vanilla NER models, these older ones, you just need to find the one that works for you. In the case of this LLM based one, you don't need to do that. It does on its own. So okay, so now we have another input. So this is oncology related. So you see name of metaplastic carcinoma. So this is the input, and here I could just simply say name of cancer and stage. I only need these two things. So here's the thing: variant and then print. Now, once I start to put in other stuff, stage, grade, size, it knows that there is only one metastatic metaplastic carcinoma that has all of these things. So the output changes accordingly. That's the whole point. And if there would be multiple of these things, then you would have, because it's a list, you would have multiple of these sub dictionaries without, or sub JSONs within the main JSON. Yeah. Okay. So this is essentially it with the case of NER NER LLM. Using it and loading is exactly the same as others. It is very easy, and yeah, all you have to do is just adhere to your input schema, which includes these two placeholders. That's essentially it, and a valid JSON. One other thing is that if it is not a valid JSON that you're inputting, then it might cause a bit of an issue, because this model is trained on, when we trained it, we did not include any such variation or did not do any such mistake. So it can throw it off. And the reason why there's a workaround for this. Instead of defining it in string, you can define it as schema like this, schema is equals to this. And then you could just simply do, schema underscore, let's say str is equal to json.dumps, dump as, and schema, and then equals to 4, and then we could just use this over here, right? And sorry, you see, otherwise it would give you garbage output. So yep, now it's fine. So I had to format this string, okay, so this way, if your JSON is invalid, it would get, you would just know right away that, okay, my JSON is invalid. That's a foolproof way of doing this, and this is something that would naturally be done if you're using it in function calling, API calling. Naturally, you would not get a malformed JSON, right? So that should be taken care of automatically. But I'm just saying that if you're just experimenting, then this is something that you can do. Now, coming to other things. RAD models and all of the other things that I was explaining, why should you use different chunking strategies, etc. So, and why do we have RAD models as well? So let's talk about that. So the third thing is we have very bespoke RAD models, RAG elements, and those are, so the way those are trained is there are multiple concepts over here, DPO, HPO, etc. Right? So preference optimization is something that when you go to ChatGPT and you ask, just interact with it, and it asks you for your feedback. that is where the preference optimization is happening. DPO, directed preference optimization. So it uses your input to improve itself, right? So that data is being logged somewhere, and then that data is being used to give you output which is more to your liking because you interacted and you provided your input, right? It's the same case. So RAG LLMs are also slightly fine-tuned in that regard. You have multiple chunks coming in, and the LLM's job is to then filter and create the best output, right? What better if an LLM is not fine-tuned fully for that task, it might not give you very concise answers, or it might leave out a lot of information that you don't want to be left out, like that you want in your output. So there are two methods to deal with the problem. One is to tune LLM. To be honest, this is not the ideal one, but we've still done it, and I'll explain why. And the second one is to improve your RAG strategy, like your indexing slash retrieval strategy, essentially, right? Strategy. Those are the two things that you can improve on, because if you're just giving totally unrelated chunks to the LLM model to generate an output, then you're not doing the model any justice, right? What's the point? So you have to be sure that whatever is coming out of your vector database and whatever you're doing in terms of indexing, the chunks that actually get to the LLM are useful and relevant chunks. So this is the one that would actually make the most impact. But the first one, as I explained, so to tune the LLMs, we use the DPO data sets, and the benefit of this is the output is more specific or more personalized to your use, to you. And this is the only benefit of using a RAG model, right? Similarly, not even RAG LLMs, but we also have RAG optimized embeddings. That as well, it's the same concept, that to improve your indexing and your retrieval. So in short, these RAG LLMs, whenever you have to combine, or when you have to put an LLM in front of RAG, I would use these RAG LLMs because they're DPU tuned, so you would get slightly better output. Even if you get the same input chunks, the output should be a bit better. Then the second thing is improving your retrieval strategies, and these are, so we already have a built-in DB inside our library that you can use. So I can link the notebook. I can provide link to the notebook. Right now, I'm just trying to explain what is going on over here. What are the challenges and what is going on under the hood. So as I explained, the main thing is to improve your indexing or your retrieval strategy. That can be done using multiple ways. One, if you take so first thing is naive chunking. Let's just do, you do naive chunking, right? Based on simple length. Okay, you just say, okay, divide the document by 200 characters or 200 tokens, right? First thing is you have to define, or you have to be very careful, what is your length. If you are creating chunks that are too long, that is no good, because when you embed a longer context, the embeddings are very diluted. So the first thing that you can do is improve your embeddings, and there are various ways. Like I said, first thing, and for that, first thing you can look at is just that the length of the chunks should not be that big. Very simple, not very lengthy chunks. Ideally, what we've seen so far is maybe 200 tokens is probably the sweet spot, 100, 200 tokens. But here's another thing. You cannot just simply split a document, because if I split, let's just say I have this document, this small document, if I split based on token, maybe it splits right like this, and my information that I'm trying to extract is now splitted across multiple chunks, and it loses its meaning, right? So there's another thing that you do on top of this. So you use smaller chunks, but then you have a sliding window operation over here. In short, they need to have an overlap so that you don't split information into separate chunks. And yeah, so reduce your split chunk length and have an overlap between those chunks so that when you do retrieval at the end, you would have, when you give it to the LLM, it's not fragmented. And there are certain reasons for that. The main reason for that is, and another reason is that another thing that you need to consider, because these are all interlinked, is that you cannot have too many chunks. Yeah, you should not have, exclamation mark here. You should not have too many chunks for your LLM. Why? Because it, again, it increases the context it has to deal with, and the drawback of that is lost in the middle, right? Things that are in the middle would get lost again. So your number of chunks that you're passing to the LLMs need to be less. That not only improves the output, that also improves your runtime, computational runtime. So that's another benefit of that. Just like we have lost in the middle in LLMs, where it slightly pays less attention to something in the middle, we have similar problem with, not similar, but kind of like, yeah, kind of like a similar problem while retrieving as well. So here's another thing that helps while retrieving. There's a concept called where you take the most relevant or similar chunk, and then you take least relevant chunk. Of course, you cannot just simply take, you cannot just simply say, okay, out of 1,000 different chunks, take the most relevant and then take the least one. No, you have to define it with a window. Let's say you pick most relevant 100 or 10 chunks, and then you create an overlap between them where you pick the most relevant one, then you put the least relevant one ahead of, like just after the most relevant one, and then you do it vice versa. So that way, LLM is now looking at the full context. This is something that helps, but there's some drawbacks as well. Like if you do, it cannot necessarily need to lead to good results all the time, but if done properly, this could lead to really good results. Why is that? Is because think about it, when you are doing RAG and you're just relying on similarity, then all the chunks that you get at the top are very similar to each other, which means there's less variance, right? Which means that all of them are essentially repeating the same, more or less the same type of information, right? So what your LLM is doing is literally, it's discarding a lot of that, or just summarizing a lot of chunks in one, and it's not getting more information that might be relevant. That's the logic behind why we pick some of the lesser relevant or chunks that have less similarity, and we just put it in front of the LLM and let the LLM decide, okay, should I include some of that information or not? In some cases, it might find it useful to include that information. So that is one other strategy. Another final strategy, and this is the one that works the best, is again to use, as I explained earlier, just use NER model to rank and generate your chunks in the first place. You have a very large document, do not just create 200 token chunks. No, run it through NER model, find areas where you think or where the model has found something, and then just store that information. And you can even rank it based on how much information are you finding or how much diverse information are you finding. For example, the NER model can find, let's say it found on page 1 to 10 all the vitals, and then let's just say page 1 to 5 it found some conditions, and then from let's say 10 to 20 it found vitals, and then somewhere 50 to 100 some drugs or whatever, I don't know, 50 to 55 some drugs. So you could use this information to either create chunks, first thing, obviously, you would only pick that one. But then when you're feeding it to your LLM, you can, instead of picking less relevant and most relevant, if your question wants to have conditions paired with drugs, let's say your question is give me give me the drugs for a condition, I don't know, let's say atrial fibrillation. Then in that case, you would, the chunks that you would put out in front, that you would retrieve, would be from this as well as from this. And then let the LLM decide. Then what the LLM would do is, aside from creating a nice output, what it would do is then see which of these drugs are actually relevant for this specific condition, and then generate the output for you. This is the core power of using bespoke models for very specific conditions and use cases. This would give you maximum output, because as the LLM is tuned to discard useful information and only give you output that is required, similarly, you're improving your chunking strategy as well, right? So yeah, this is where this entire puzzle comes into play. Okay, so this is NERs, LLMs, how do you combine them, and how do you use them properly, or different, different techniques. All of these techniques and these experiments are out of the box in the library, and all you have to do is, like I just showed you, using them is pretty easy. These chunking and rags, all of this is also pretty easy. It's just a few functions. But yeah, this is what is happening underneath. So the main reason of explaining this is so that when you run and you see a different output, then you would know which knobs to tune, etc. Because these are all essentially knobs. These are all hyperparameters over there that help you understand what to do. Okay, so now we can, I think, jump onto LLM Studio, because I just explained all of this, showed you code, how to use it, etc. But what if you don't want to do that, right? All you want to do is just run something locally within your infrastructure with a nice UI. This is where there's a slight tool, LLM Studio. It uses all of these models underneath, it does all the same things, but with a nice UI, like I showed you here. All you have to do is just clone our repo and then just include the JSON file, the license, and that's it. It would build infrastructure for you, it would run an interactive app for you, and all you have to do is just interact with it. So if you are an MD or you don't want to get into the technicalities of it, all you want to do is just run some quick experiments, then yeah, this is the perfect thing for you, because there's literally no coding involved over here, right? So you go over here, and main thing is this runs on-prem. Like you could just start an EC2 machine, install it over there. This is what I'm doing even right now. This is an EC2 machine, that's it. And everything is running on it. So over here, you can check your deployment status, which model is being deployed, your system status, how many GPUs are available, etc., all that kind of stuff. And you have even an API endpoints for people who want to use the same thing using API. Let's say you want to deploy something, etc. Yeah. But the main thing is you can just choose the models. These are all the available models as I showed you earlier. The same ones, META, MS, NERs, RAGs. And then you just choose one and then redeploy it, that's it. Or offload that model, for example. Right now, what I've deployed is this one, META. And yeah, again, it's free text. So just enter your own text or choose one. Let's just enter your own text. And then I think I just tested it with something like this. What is the age of the patient? And then, so it's a 56. I just hit generate response. It runs the LLM and then just gives me the output. Very simple. And you could do all sorts of prompt engineering. You could even use the META NER model here, this one, and just provide your input over here, and it will run it for you. So this is a very simple thing that can help you without delving into the code base, just for experimentation purposes. Okay, now, so this is LLM Studio. This is a very simple, small app. Now I want to show you something different, and that is voice assistant. This is a new thing that we're developing. Just give me a minute. Okay, yep, I think you can see my screen, right? Yep. So yeah, so this is a voice-based assistant. Let me first explain what is going on here. So the idea is that instead of typing everything and interacting with LLMs, what is happening in this case is it's a small app that's running inside your browser in your local environment. Not all of what I just explained is all in your local environment. Nothing gets sent out to the cloud. So you have your own voice assistant engine that's running in your environment, let's say an EC2 machine or your on-prem environment. And it's a small app that runs on top of your EHRs or on top of your, yeah, mainly EHRs. This is designed or geared towards doctors. So when you're seeing patients and you're just having that conversation, this would record everything and then fill out forms for you. Right now, we're at the stage of extracting and filling out PDFs and Word documents. The next stage is to simply connect this with the EHRs. So all of what you just say, all of that would get formatted and stored automatically in those, in those digital forms and inside your EHR. All you have to do at the end is just, you know, verify whatever input whatever the model has inputted or filled out for you. Is it true or not? Is it correct or not? And then just make adjustments or just click submit. So essentially, it's fully automated data entry. Okay, so here's the thing. Here's how it works. So this was recorded. This is a live uh, doctor interacting with the system. So as you can see, it's real time transcribing whatever they're saying. And not only that, it's fixing, like you would see text change based on what they're saying. It would fix on the fly. And then, yeah, just give me a minute. It's a short encounter, but yeah. So it's an asthma patient and she has not been taking Flonase and had wear, but some reaction and her vital signs. Okay, so pulse is 72, 97.1, and okay, so asthma seems to be worse. And she is just using her Tribento inhaler, but is using it daily. So now it's the suggestion we will add flopin, 44 mg, and following for reevaluation in 1 month, we will plan on starting Allegra and Flonase for the time being. Okay, so that's done. And then you have the option of fixing the transcript like this. So it would fix any mistake. Let me just stop it here. So for example, if you removed okay, it just made it a bit more professional, and that's the whole point, right? You can talk in your natural flow with stop words and other type of not your normal conversation, and then it would fix all of that for you, generate a nice professional PHI in your own format or summary, whatever. This is all configurable. And then the main thing is that you would be able to fill out form. I have already put in a form over here like this. This was essentially a PDF that got converted to text. And then you'll see that now the form is also auto-filled. You see? So vitals are filled out as a table, medication list, revised problem, initial problem list, and then name, date. So this is something that is coming from EHR, by the way, because you might have noticed the doctor never said that this is the patient's name, right? So and date. So this is directly coming from EHR, and there's a lot of stuff that would be. So it's a full integrated solution that integrates with your EHR. It knows what chart is open, of course, and then it would provide that auxiliary information underneath to the models that are running, and you would get the final output. That's the basic idea over here. Yeah, anything else for this? Yeah, no, that's essentially it. So yeah, and okay, so there are a few other things. I think I showed you here. Yeah, let's pause. So in this video, we only demonstrated fix and autofill form. Find entities is literally NER model that I just shared with you. So it's for function calling, and it's for automatically populating in relational databases or non-SQL databases, etc. This is an additional functionality. The core functionalities are fixed transcript, autofill form, generate Q&A, and diarize. In this demonstration, there was only one person. It was just a doctor. Diarize is for when you have patient. So in that case, the concept is you monitor the entire patient doctor interaction. If it's a 30-minute one, you monitor everything. Then you diarize it. What that means is that you take out the entire conversation and then you assign speakers. That, okay, this piece of this transcription is from speaker 1, then this is from speaker 2. You identify number of speakers, then you assign parts of transcripts to each speaker, so that you know what each person said, and this would be the fully diarized transcription that you can use or store for your records. Essentially, it's for storing in your records. Or it's not even storing for your records. You can just prune or simply say, okay, I don't want the information coming from patient while I'm filling out my form. I just want to have validated information from the doctor while I'm filling out the form. So then you could just have a toggle over here that exclude other speakers and only use the information from the doctor while filling out the form. But yeah, that's the basic idea of this entire product, that you don't need to type in. It reduces your manual data entry time. Okay, so yeah, that's essentially it. We're almost on time as well. I'll look at the questions. Please feel free to ask any question regarding anything. And yeah, thank you for joining in.